Folks, my name is Hamza, and welcome to the series where we interview the industry leaders in the plastic injection molding industry. I am an account executive at Simform, a division of Maya HTT. Maya HTT has proudly served more than 7 million users across the globe in the last 40 years in the 3D simulation and software engineering. Today, we have a guest who is a pioneer in the scientific injection molding industry, someone who has trained hundreds of individuals across the industry in scientific molding and whose experience and knowledge is unparalleled and most sought after. Mr. John Bozzelli, how are you doing today?
Fine. Welcome to be here.
Thank you. Thank you for being with us today. We sincerely appreciate it. So why don't we start with you highlighting a little bit about the injection molding solutions that you had?
It's a small company. It's just me. I'm basically a consultant and trainer. I travel to various companies. I have in-plant seminars. I also have a facility here in Midland, Michigan that I have 3 machines, and I do training as needed on my scientific molding topics. They go pretty well, 3 days, and you're in and out. You get some hands-on stuff. So that's basically what I do consulting on the side, travel to some companies, not doing too much travel now as I'm getting into my older ages, as I've been in the business for about 45 years, and age-related issues as well as a little, let's say, hesitation about getting on airplanes anymore. It's just not much fun.
I see.
Moving on to the next topic.
It goes without saying that we have heard, many of the individuals within the industry who proudly say that they have had a training or a seminar from you, though. So that's amazing. How long have you been doing these seminars, though? Is it for the last 40 years or the last 30 years?
Actually, I worked for Dow until 1992, and ever since 1992, and actually started seminars in 1990. Dow actually supported me to do seminars, and things changed, and I left and worked with Rod Grello for a while, and then I went on my own, and so it's ever been since 1992. So it's been a number of years, a couple decades and more.
It's been quite some time, certainly. I'm considering you have been in the industry for quite some time. Would you mind expanding? What are the few challenges that you mostly face in the plastic injection industry? Whether it is from the mold designer side or molder side, or just an overview at large.
Okay. The way I approach it, you start off with piece part design, then you go into tooling design. You either go tooling design and construction. You also have to pick a resin selection and handling. Then there's processing, and then there's testing. And there's a reason I call my company Scientific Molding, because it's based on data. It's not based on opinion, which I'm sorry to say the bulk of the industry is. This is the way I've been doing it, or this is the way I know to do it. Reluctant to take outside information, as you probably know. Even getting the software you use interpreted correctly and read correctly and paid attention to might be, I'd say it's difficult. And a lot of people don't do what they need to from a data point of view. And I try to, when I do the seminars, I build a process. First go get data, then make decisions on what I'm going to do for processing based on that data. Basically.
Amazing. So you rightly highlighted that the data remains the core center of your teachings and even when you're doing the analysis, though. Considering many of the mold designers, as you rightly said, just like to say that we have been doing this for quite some time, do you observe a change when they come to your seminars and actually have learned from you? Do you think they go back and actually change their ways of doing things? In other words, relying completely on data?
Well, certainly some of them do. They've made remarkable gains, and their companies are growing by leaps and bounds because they base it on data. But all of the 5 categories needs to base it on data. Getting people to work by databases rather than by the way they've learned it, are trained, and sometimes a lot of them are trained wrong. But we can actually just take a particular topic. Let's take cooling, for example. That's one of I'm going to say at least 80%, 90% of a cycle. It's got to do with mold building, processing. And there's something called a Reynolds number. I'd be surprised. I'd love to be able to take a poll of your audience and how many people understand what a Reynolds number is. It's based on data. It's got to do with water flow and how you take the heat out. You either do it that way or you're not doing it correctly. And I'm sorry to say, but I don't mean to embarrass anybody, but 80% of our folks, I would say roughly 80% of the folks molding, don't pay attention to GPM, gallons per minute, or liters per minute, and temperature in and temperature out of each of the water lines. It's sorry, you've got to have that data or you don't know what you're doing. You're actually probably losing money because cooling is 80% of your cycle time.
Very true. Considering cooling accounts for 80% of the cycle time and really can make or break your plan from a profitability point of view. Do you think there would be a possibility where mold designers or molders would be willing to use any kind of a software that can really guide them to identify that they would need to install cooling lines at one place over the other?
Certainly that's necessary, and we need to do that. But you need to do the calculations for the Reynolds number, which your software would probably do. Then you've got to get it done on the machine. And the 2 things, getting the calculations done and then getting the appropriate water lines, measurement things. And this is what you learn in my seminar. There are tricks to make this easier because it can get too scientific and then it just becomes mind-boggling. But we got to break it down. You got to do the basics and get them done as efficiently as possible, might be a good word, and also user capability in hand, where we're not buying super expensive equipment just to calculate a Reynolds number. We're going to use some basic equations, plug in software, and go with it. And then I have some mechanisms on how you hook up lines. Just to give your audience an example, is that I think anybody who's been in molding on mold shop has found that they've hooked up the wrong lines to the wrong ports on the mold. And one of the things I have is that all the ins are males, all the outs are females. So you can't hook in it the wrong way. Everything else, 90%, everybody's the same fitting. And it's confusing, which is part of the situation we have to deal with. The pressure out on a machine to get things running, get it fast. It's dirty, it's hot. It's sometimes dangerous, or you want to be considered the temperatures involved and pressures involved. So, lots going on in processor's mind, or even the people who hook up the molds. But this has got to be done right in order for the cooling. I don't mean to push cooling too much, but it is probably one of the ones that are least done correctly in our industry.
True. And would you also say that not only cooling has an effect on the cycle time, but it can have an acute effect on the product quality as well?
Oh, absolutely. The number of projects I've been called in on as a consultant because of warping afterwards or something like that, and it's got to do with cooling, understanding the plastics also. That's my background's polymer, so that does help. But the combination of all that, I would say that's probably maybe 60% of my consulting time is trying to deal with issues once the mold's made and we're making parts, but they're not too spec.
Mm-hmm. And manufacturers or molders who maybe are not seeking your services or let's say are not really using the scientific molding principles that are in place. From your experience, what are the substitutes that they're trying to use to make themselves more efficient right now?
Well,
Like a standard checklist, you would say that they just do it for the sake of it.
well, it's you go to somebody's seminar, and I would say, I'm going to recommend mine, but Rolos are good, but my Paulsons are good. But you got to do the science of it, which is not being done. And the other problem is today, I think, is having free time, or having time that you could actually let one of your processors go out to a seminar, because getting qualified people and enough of them in your shop to work on these hot temperamental machines and whatnot, finding processors is extremely difficult. And they also need training. Some of them have been brought up just by seeing others, and there is, by going to the right trainers, you can get some tricks and methods that are, let's say, scientific and yet still easy to implement. So that's what needs to be done for your plants to progress and stay alive in an ever more competing world market that there is.
All the minute details that mold designers and molders need to take into account. And from your experience, would you say what percentage of individuals are really going above and beyond to making sure that they're measuring the temperature, measuring gauge and everything, and trying to measure everything though?
I don't mean to embarrass anybody or be condescending, but my guess is less than 25%.
Less than 25%. Okay. So indeed, there is a lot of learning and to do. Goes without saying.
It's not just learning, there's the implementation. One of the issues is I have people come to the seminar, they're not the owners or the managers of the company. They may go home and want something, but the budget cannot afford, which is hard for me to accept, that they need these gauges or these implements to measure gallons per minute of water and temperature. There are expensive ways of doing it, but there's also relatively inexpensive ways of doing it and getting the data, applying it. And infrared guns in my career, when they started, they were, cameras are in the $70,000, $80,000 range. Now you get that same camera for probably 3 or 4, but also all the other stuff has come down. Actually, one of the more expensive things is the gallons per minute monitor. Those have gone up in price, but you still need them. You have to know the GPM going through those order lines. Most people don't do that. They just hook them up, and they might know the GPM put out by the temperature controller, but you don't know how it's distributed through the different lines. You have a big line, more water goes through the larger diameter line than the smaller diameter lines. You got a bath or a bubbler, probably not getting very much water.
And in order to know those tricks, we gotta attend your seminar. Indeed.
Well, no, I'm just giving you the tricks. You gotta have something that measures GPM and what. There's different things that do that, but you just gotta make it easy. The one trick you might learn, it's not a trick. Just, some people hook up one line for every port in and out. I loop them as much as I can, because if I monitor the GPM, like on my machine, I have, it's relatively simple, true, but I have one in and one out. It's got 3.6 gallons per minute. The Reynolds number is like 40,000 and minimum's 5. And I bet you I do that for less than, not counting the cost of the temperature, the mold temperature controller itself, the gizmos, the GPM and the temperatures. I bet you I have less than $200 into it. And that will service any mold.
Mm-hmm. So that is relatively very inexpensive. That's good to know. Other than that, do you see any emerging trends or advancement in the mold cooling technology that you find interesting or promising?
Well, the GPM gauges are getting a little bit better and more reliable. That's good. There's the software, like what you do and whatnot that tells you what you need to have. That's a good start. And a lot of them don't get that. I'm not sure you do it. I'm not sure it gets down. That's one of the problems. I'm not sure it gets down to the molders or the processor that this is what's required for this thing to run right.
And if I may interrupt, how do we get to molders and processors then? How do we get that information then?
Well, that'd be curious. I don't know all the steps. People certainly come to you to do the software analysis, right? And who do you send it to? You send it to those people. Now, do those people communicate with the processor? And not only, that's probably not even, and you wonder, the company that builds the mold, is it the mold shop or is it the company that's using the product? All that got to be ferreted out, but you need to get it to the processor's window, say, into his world and what he needs for that mold. That ought to be, I ought to have a little book that goes with the mold, and all this stuff is in it at the beginning, and then every time it's mounted, things are checked off, and then of course, a lot of shops do mold maintenance. That's got to be done, and so they'll have a book on that. That's nice to have, and the molder processor should have access to that.
Indeed. And so recently we have noticed that a lot of simulation softwares have really started to become more democratized and commercialized within the industry. Do you perceive simulation softwares to actually take off within the industry, so that even a small molding shop would be having access to it at within a few years or something?
As you know, the cost of it is a significant barrier, and some people are worried about it. And then they also were wondering what the interpretation is. One thing I will say, you do better for yourselves to deal with the clients in their own language. A lot of the software I see is in metric, and of course the U.S., and unfortunately we are wrong. I'm not saying, 90% of the world is in a metric system. We're still trying to hang on to the English system. There are only 3 countries in the world doing it, and we're wrong. And nobody wants to admit that. And unfortunately, though, there are people who have problems, and even I get fouled up, converting periodically. It's a problem. So when you give your software out, I would like to see you do both metric and English in terms that company is dealing with. So that's one less step or barrier for them to jump over that hoop to get what they need to get done, if that makes any sense.
No, it does. It does make sense. So price is indeed a barrier that we have even discussed with many of the mold designers and molders. Is something that small mold shops are not they do not have the financial capacity to pay $2,000, $3,000 for those expensive simulations. So in your view, would a cheaper simulation that nudges a mold designer in the right direction could be useful for the industry at large?
Certainly, if you lowering price would be better. The other thing is trying to sell it to the customer, because the customer would get the benefit of this, and you're helping then the molder and do some of the sales pitch or the grunt work to get the customer to help pay for it, to get everybody gets the benefit.
True. And as long as we can involve all stakeholders within the system, the better it is. One thing we have also noticed is that there is also a little bit of reluctancy in order to adapt new technology and software within the plastic injection industry. How do we go over that, or how do we overcome that?
I've been fighting that since day one. We are a group that has died in the wall. We do not want to change unless you're beat upon. I don't have a good answer to that. It's one of the hardest things I have to deal with in my training. And this is the way they learned it, and they're not going to change because this is what they're comfortable with. I call them crusty senior. They just do not want to. And sometimes I'm crusty senior too. I'm dyed in the wool on my way. So I don't have an answer for that other than present them with the data, try to prove it to them. Like I try to do it on their molds in their shops when I do it. And some people become a believer, and some people just, are happy doing it the way they're doing it. I've been fighting that my entire career. I don't have a good answer other than find somebody that's, or when you start out, get them started out in the right direction rather than, it's much harder to learn something wrong and then try to correct it later on. If you can learn it right from the beginning, that's a step in the right direction.
Do you think it is expected to maybe get better as we will get folks who will maybe retire from the industry and new folks will come in?
You got an issue there. Certainly the new folks have the ability to be trained correctly, but the way, and I mean no insult to anybody on this, but most people now, more and more, because of the computers and the fun of dealing with the computer and doing it and not getting your hands dirty, not worrying about high temperatures and high pressures and getting hurt as much as you can on an injection molding floor. I think there's a real barrier there for people who want to get their hands dirty and work under these conditions. A lot of molding shops, if you've been in them, I'm sure you've seen, they're hot during the summer. They're not very clean. And you're working with high temperatures and pressures. You have steel, tons of steel to move around. You got to know what you're doing. You don't want busted fingers or health issues, safety issues. I think that's a real problem for industry. That's not you or me or whatever. It's, if somebody can make money sitting at a computer, they'd rather do that than the labor of dealing with, molten plastic and molds and whatnot. I think there's an issue there. I don't know how to address it.
Yeah. I think maybe the effort will take from the whole industry. Maybe everything will have to do their part so that we change our ways.
Or if you pay them, I mean, if the pay, I should mention that pay scale needs to be adjusted for the risk that these people and the type of work they are doing. That would certainly help. But processors are still low on the total pay.
Now that's a very a good response. I think if you incentivize them financially, they may be willing to change their ways.
Well, it's not just incentive; it's let them have a say, which usually they're getting it from the top down, and they're pushing something up as hard, but also a clean environment. I work very hard to keep. I actually had people come to my seminar. My machine is like 6 or 8 years old. One of the people says, "I can't believe it's so clean." Can I take a picture of it because it's clean? Little things like that. It takes a little effort, yes, but it's not dripping oil. It is an electric machine, that helps. So it's not dripping oil and whatnot. But that's it's clean and it's nice. It's higher tech. I think you'll attract a little bit more people than greasy monsters many of the guys have to deal with.
Yes, we have seen everything on the floor. That goes without saying. Let me ask you a little bit more of a challenging question. So, of course, you are the pioneer in the scientific molding, and you really have a way of presenting data in a meaningful manner. But when we talk to mold designers who are designing mold, they perhaps say that doing it scientifically or trying to incorporate data as a whole actually kind of makes my job much more difficult than easier. Why should I pay excessive attention to a scientific way of doing things if I can just simply ballpark it and make the mold design? He's not getting penalized, or he's not getting incentivized to do his job better.
Well, difficult question, but there are some of the tools that don't work very well, and you wind up paying for a lot more trying to get it back right than rather doing it right the first time. And some of them are very good. the other issue is you do have some tool builders that have been in it long enough. They've got some very good background on what works and what doesn't work. And you need both. I mean, you got to listen to what they've got to say. Calculations are one thing, true experience, and those needs. I mean, it continually, all the software needs to be meshed better with real life versus theory. But you're right; it's still an issue. I would think that if you found somebody that talks their language and they have some respect for that, that's been in their business, it might be a way of getting their ear better.
Mm-hmm.
That's about the only thing I can come up with. I haven't thought about that question very long.
Yeah, because correct me if I'm wrong here, because if a mold designer does not incorporate the principles of scientific molding and goes on to design it, it's the OEM or the molder who's taking the brunt. Very rarely we see that the mold designer taking the brunt for it.
Right. You have a very good point. I can't argue with you there. They do it and then they toss it over the fence, the wall, and they don't see much of it all. And then the processor and the rest of the folks have to deal with it. Mm-hmm. If you can find a way to get it back to them and have them have some repercussions for when they do something wrong. The big thing is before you cut steel is to have it reviewed and then discussed. This is what we find. Why are you doing it this way? And try to explain. Both sides will have an input, get both sides to talk about it, and then go from there. And I believe that's a problem, is the discussion business. They're busy, especially tool makers. I mean, we don't have enough of them, like we don't have processors. So all this takes time, and they'd rather do what they're comfortable with rather than learning something that may be new or is not really their bailiwick, not something that they're familiar with.
Very true. And do you think some standard operating procedures or some standards where a molder or an OEM requires a mold designers to either use scientific principles or some kind of software, perhaps, could be that beginning where it could be helpful for them to pivot to the right direction?
The one thing that I've had lately in my seminars, not trying to, I can't answer your question directly, but this has helped, where actually I've gotten some mold builders to attend my seminar. They're coming along with their processors, and all of a sudden, the light goes on that, they build the mold, but then you also have to process, and now they understand a little bit more about processing. So they're more willing to, let's say, do the water channels. They're checking. So you have a case history where people spent $250,000 developing the process. They did what they call the DOE, a full-fledged design of experiments. Spent $250,000, couldn't figure out anything, and I was involved with it to an extent. And then, like I said, we went into don't start taking data until the mold steady state temperature, and sure enough, it took 40 minutes for the mold to get to steady state. And that's because one of the water lines was partially blocked because the gun drill wobbled a little bit. I mean, if we could have caught that in the beginning, that would have saved at least $200,000 of the $250,000 they spent, because we would have stopped the DOE, because the mold kept getting warmer and warmer and warmer as we made more and more shots.
Great. Another question that I have is, we have also noticed that there is sometimes either miscommunication or even a conflict between the mold designer and the molder. A mold designer thinks that he has a right way of designing it, and a molder is thinking, wait a minute, I need to maybe reduce my cycle time, or when I am producing the plastic part, it won't going to produce the quality that I want. And as a result, there's a miscommunication and a gap that cannot be filled. Do you think a front-end simulation software, where basically a simulation that is done beforehand before the mold is designed, and the results are passed through the mold designer and a molder, can be one way of reducing that miscommunication, or bringing all the stakeholders to one point.
Yes, I think that's definitely a direction, but you've got to present it so that each of them understand it in their terms.
Mm-hmm.
I wish I could, define that, but just like, you've got to talk in metric to the metric people, and you got to talk in English units to the English people. And another issue might be, to your benefit, can you find somebody that bridges the gap, that knows what you do and knows tool building, and bring them in for the discussion? Because, if they know the language that each of us speak, I speak molding language or processing language. I'm not a tool builder. And I have tremendous respect for these guys. Can I talk to them? Not as clearly as, like, I worked with a guy named John Cleese. Now, his background was a tool builder, but he also knew processing very well. We gave seminars together, and those seminars were even better accepted because now we had, people talking to each of them in their language and crossing the barrier between processing and tooling. And they went over extremely well. So it helped both John and I, because we would go over issues, some of it was his ballpark, some of it was my ballpark, and we'd argue, try to rationalize, what's the best thing. But, we got along, we were friends, and we were trying to do the best job. It wasn't, I'm right and you're wrong, which some people get. It was, what's the best way to do it? And there were a lot of times, to be honest with you, I was pretty hard-headed, and John Cleese was just the guy to break my hard head and say, no, you got it wrong and you got to change. I think I did a couple things for him too.
That's good. Yes, indeed, it goes without saying, as long as both parties are coming in with an open heart, to accept the results in a way that benefits the molder and the mold designer, I think should be right. I think it's very important, your insight, that you got to speak to them in their language. So I think maybe a software that interprets the results for a molder in a way that speaks directly to them in their language, and to mold designer or tooler in their language could also perhaps be helpful. Or
well, one thing that's come to mind is, if you had a case history where you did involve people you should involve from the beginning and work through it, and this is how it went, and here's what, you could sort of point at, this is what the designer learned, this is what we learned, and this is what the processor learned from this experiment or this flow analysis that you did. If you could, get a video of that, or, to show, and but find some things that were really meaty, like this part was thicker than it needed to be, we found out, and so we could save plastic. And then now we need to get the cooling lines where they're supposed to be, so we save cycle time. And these are your driving motives, because it's going to get you a part faster at a cheaper price. And that's what it is. And with the tooling capability we have today, the new machines that are coming out, and in the imprint molding, mold building, all that is, like making a bowl. The old way to get cooling lines in it was you drill holes. Well, you can't drill a hole circumferentially around the bowl. How do you get proper cooling? Sure, we made the bottom out of, like, we used to make them out of beryllium copper, high heat transfer steel, but there's issues with that, and there was no way of making circular line. Now today we can print a mold and you can have circular water lines. These are big deals. These are game changers.
Those were all the questions that I had for you. Do you have any parting or last thoughts that you want to leave?
No, I think the sum of it would be, there are 5 key components to make a good part. You have piece part design, tool design and construction, resin selection and handling, processing and testing. Nobody can be expert in all five areas.